All right. Good morning, good afternoon, or good evening, everyone, depending on where you're joining us from. Um, Welcome and thanks for being a part of IIoT World Manufacturing and Supply Chain Days. Before we dive into this afternoon's panel conversation, we are going to take just a couple minutes for some housekeeping. So I'd like to start by just getting everyone familiar with the webinar tool. So take a look around for the chat. And if you can tell us where you're located, we'd love to hear from you. Alternatively, we're going to be taking some questions here at the end of today's conversation. So if you could post those in the Q&A tool and not the chat, it'll make us easier to answer those at the end of today's panel. I do want to let you know about some other upcoming events from IIoT World. First and foremost being day 2 of this event is tomorrow, December 8th. Make sure to come back for the next day of Manufacturing and Supply Chain Days. After that, here are a few more to keep on the horizon. We have All Things IIoT Day on January 26th, 2023, IIoT World Energy Day on March 2nd, 2023, and IIoT World Manufacturing Day, May 17th, 2023. So like I said, we're going to be taking questions at the end. So please make sure you're posting those in the Q&A tool. This session in total is going to run about 58 minutes. So we'll make sure you're ready to go for your next session after this. But before we begin and before I introduce the great crew that we have here today, I do want to thank our sponsors that have made this virtual conference possible. So a big thank you to Hitachi Vantara, HiveMQ, Faircom, Fortinet, Eurotech, Oxys, Building Cybersecurity, Axana, MSA, GE Digital, IFM, Intel, Litmus, and NCC Group. So thank you all for making this possible. And with housekeeping out of the way, I want to make sure I introduce our topic and speakers. So our topic today is cognitive planning and AI-driven predictive analytics for supply chain and manufacturing. Now, what does that mean? Well, we're going to cover essentially 3 topic areas in our discussion. First being, hey, how predictive analytics are used to predict failures in manufacturing. We'll start there. Then we'll shift the conversation to the benefits of predictive maintenance over traditional maintenance. This is where we'll be spending a bulk of our time. Then finally, we'll talk about how to collect and analyze IIoT data in manufacturing before we get to the Q&A. So now I'm excited to introduce our 3 panelists today. First, we have Martin Davis. Martin is the CIO and managing partner at Dunelm Associates. He's had extensive experience across automotive, manufacturing, consumer goods, food, transportation, and financial industries, where he's delivered value globally at both large Fortune 100 companies as well as privately owned companies. He focuses on high-quality business outcomes, which result in customer satisfaction and return on investment. We also have Cliff Emmons. Cliff is the CEO of Oxys and a visionary medical leader with extensive experience in creating, building, and transforming research and development organizations. He's done this in the US, India, and China at Fortune 500 company with a Fortune 500 company with over 200 engineers and multi-million USD R&D budgets. And then finally, we have John Murray. John is a business development leader with over 20 years experience in wireless communications, Industry 4.0, and IIoT. John has helped industrial companies with IoT connected product development and introducing new manufacturing solutions that help reduce operating costs, increase quality, and improve overall profitability. Currently, John is responsible for growing ConnectIO's North American market for its asset minder condition-based monitoring and predictive analytics solutions. And with that, that was a thorough intro for some of the great panelists we have here today. I'm about to fire off a bunch of questions to them. But first, I have a question for you. And to add some context to that, I should introduce myself as well. My name's Chris Lukey, host of the industry podcast Manufacturing Happy Hour. My favorite thing is doing sessions like this and getting people to think critically around manufacturing and the opportunities that are there. So this question is for the audience, and I want you to be thinking about this as we go through our discussion today. Ask yourself, why should my CEO care about IIoT and collecting manufacturing data, right? That's going to be a common thread that we'll address indirectly in a number of ways, right? But if you're attending this session, I want you to be thinking about that as we're going through this discussion. And without further ado, let's dive on into question number one. So a basic one to start things off, and this is for two of our panelists. Can you explain how predictive analytics are used on manufacturing equipment to predict failures? John, let's start with you, and then Martin, I'd like to get your take on this as well.
Okay, thanks, Chris. Before we start there, I think what we want to do is just set the framework. What is, again, predictive analytics for manufacturing, and why is it even used? So one of the, an important thing is right now, unplanned downtime in a factory floor is anywhere between 5% to maybe 15% of a time a factory is not producing because of unplanned downtime. Most of unplanned downtime, about 50% of unplanned downtime, is caused by mechanical failure of the production line. Another 25% or so is from human error, and then the other percentages are other things that happen on a factory floor. So it is a big problem. So I mean, when the factory is down, there are raw materials there. There's expensive equipment that a company has bought. There are workers that are not sitting on they're sitting on their hands while the equipment is down. So it's a big problem. So really what predictive maintenance and predictive analytics does is it monitors the equipment on a plant floor, and essentially through sensors and monitoring equipment, control systems, etc., it can detect very early on when a mechanical failure is going to happen. That's essentially it. So what happens is a lot of times people, when an equipment is shaking and the temperature gauge is overheated, it's on the verge of failure, and it's almost too late to do anything about it. What predictive maintenance does and predictive analytics does is, every time before a thing fails, there's a lot of small incremental things that happen that lead it to fail. And really, predictive analytics, it can detect all of those anomalies well before it fails. So you may have a week or a month or even longer to know that a system is going to fail. And this is what the crux of it is. Okay.
Thank you, John. Martin, you're up next.
I think just to build on what John said, if you think about what happens in terms of the sensor information, the data you get from a piece of equipment before its failure, and as John said, it could be long before its failure. There could be many different parameters that in very small ways are changing. And what predictive maintenance can do, and good AI and predictive analytics, is taking that kind of pattern from, it could be 50, 100, thousands of pieces of information, and saying, okay, what does that pattern look like as it approaches failure? And what does it look like in its early stages? And that could be related to vibration, temperature. It could be impacted as well by external factors such as humidity, external temperature in the building, and other things like that. But what a predictive model can do is then take all that data and say, okay, here's the pattern and what the pattern looks like as we know a failure is going to occur in the future. And it could be anything. It could be from a full machine through to a bearing. And as what John says, which is, if you have a failure and you get downtime, that's going to cost you hundreds of thousands of dollars an hour. If you get a catastrophic failure, let's say it's a bearing in the middle of a machine fails, that could take that machine out of commission. It could be a $250,000 rebuild to get that machine back up and working, because a catastrophic failure of a bearing could then lead to numerous other pieces being damaged within that machine. So all of that, if you can see that pattern early enough, if you can use the modeling, the predictive analytics to say, right, that piece of equipment is moving towards failure, and catch it early enough, then you can do planned maintenance during an appropriate time. You're not actually shutting down during a time where you need to be producing. You're not got a catastrophic failure, and you can rectify that situation as early as possible.
Yeah, I appreciate you both not only answering that question, but also providing the why behind it, right? We talk about the sources of unplanned downtime. We talk about, looking for patterns to avoid failures and catastrophic failures. Cliff, same question for you. I'd love to get your thoughts, but also maybe we expand on this a bit, right? How are predictive analytics used on manufacturing equipment to predict failures, and how is your team using this information to be successful in predictive maintenance engagements today?
Sure, Chris. And first of all, I think John and Martin's thoughts were spot on, and I think you're going to actually find a lot of alignment with the example that I wanted to share, which actually comes from a use case with our Spanish partner, Ingura IIoT. The application is for a large CNC machining centers where there was a desire to predict the failure of the main spindle bearings. And the technology used to actually implement this predictive maintenance were acoustic sensors, basically listening to the condition of the bearings. The predictive analytics approach we used was unsupervised machine learning algorithms. And I'm happy to say that we actually achieved a 10x savings in maintenance cost because the customer could replace bearings before they failed, which was exactly the point that Martin was making. Also wanted to point out another interesting point that correlates with what was brought up before, was that it would actually take another 4 additional days from the time that the bearings were replaced predictively to the point where it would actually fail for real. And as mentioned before, the cost would be significant for that major failure if it went to failure. In fact, it would have been definitely a 6-figure cost to the manufacturer to replace, as opposed to a 5-figure if it was done predictively using these algorithms. So also wanted to say we're currently now working with the same partner to use this approach in other predictive maintenance engagements, as well as applying these same techniques to CNC tool optimization, which is something I'll get into a little bit later.
I love this. I think that's a really digestible example based on what we were just talking about, right? Using unsupervised machine learning algorithms and being able to replace bearings before they fail, right? If there's something I've heard a couple times, it's catching things before they become an issue is really what this all boils down to. So, now that we have an example of how predictive maintenance plays out, right? Martin, can you share the benefits you see in predictive maintenance over traditional maintenance? Let's say the way things are done today in many places.
Let's build on that example for just then. If you take a bearing, let's say its lifespan is 5,000 hours or whatever it might be. It doesn't really matter. Let's say it's 5,000 hours. If you're using a more traditional time-based maintenance approach, you may replace that bearing. If you say the normal lifespan is 5,000 hours, okay, we're going to replace it at 4,500 hours. That bearing, because of manufacturing defects, whatever, could fail at 3,000 hours, leading to a catastrophic failure, shutdown, problems, machine rebuilds, cost. Or that bearing could be extremely well made and could last 10,000 hours. So both ends of the spectrum, if you're not actually predicting using analytics or whatever, you could be either replacing it too early, when it's still got 50% of its life left, and that, and every replacement is costing you money in parts, labor, extra downtime, whatever else. Or that bearing could only have 3,000 hours and lead to a catastrophic failure, which leads to cost and everything else. So if you look at the whole picture, if you can predict when something is going to fail, you can do things in a planned and structured manner and save money. Either by replacing it when it gets near the end of life, or replacing it before it fails. Either way you want to look at it, either end of the spectrum, it's about cost, it's about avoiding downtime, it's about keeping your plant running as efficiently as possible.
Love that example, right? It's not necessarily just about addressing it when it's, at 5,000 hours, right? It could be 30,000, or I'm sorry, on the low end, 3,000, or on the high end, 10,000 as an example, right? There's a range. It's about narrowing in the spectrum to the right time rather than too late or too early. John, what are your thoughts on this question, right? Benefits you see in predictive maintenance over traditional maintenance?
Yeah. So the other part there is with predictive maintenance, you get really more at the root cause of what the problem is there, why is the problem occurring. So, for example, a bearing fails. There's a bunch of reasons a bearing might fail, as that example. However, if you're also monitoring a shaft, if you're monitoring a drive, you're monitoring a bunch of other things in the system of systems, you may find that the shaft is bent, or the shaft is misaligned, and that's causing the bearing to fail earlier. So again, the example of the bearing should last 5,000 hours, and it's going to break in 3,000 hours. Why is it breaking in 3,000 hours? Maybe the shaft that's driving that, driving the bearing is misaligned, and that's causing it to fail sooner. With predictive maintenance and predictive analytics, you can actually determine that, you can see that the bearing is failing. You can see that the shaft is misaligned. You can see other things in the system of systems that are all contributing to these failures. So it gives you a lot more benefits. The other thing is, with statistically speaking, if you look at, if it ain't broke, don't fix it. And just, so some companies do this. They just do break fix repair. They don't, they don't time anything out. They just wait for a machine to break, and then they fix it. Okay. And then other companies, they do planned maintenance with, again, based on hours of operation, or on a schedule. Every 6 months, they're going to change everything, whether it needs it or not. Those type of those two things, they don't really change the amount of downtime significantly, believe it or not. Planned maintenance does have a little bit lower downtime than break fix repairs, but not significantly. Companies that implement predictive maintenance, they actually reduce their unplanned downtime by, on average, 36% compared to break fix and then planned maintenance as well. So there is a very significant increase in uptime and productivity using that.
All right. We're going to be shifting the conversation here to a big topic that I think a number of people will want to discuss: supply chain. John, Martin, you both gave your thoughts there. Cliff, do you have anything you want to add to this topic before we dive into the supply chain question?
Sure, Chris. So I led product development teams for over 20 years, commercializing minimally invasive surgical instruments, as well as diagnostic equipment. And a robust product development process requires a really strong connection with your supply chain. Because there is a goal to optimize that so-called value triangle of performance, quality, and cost. And also, when it comes to medical devices, they often have many physical components that are dependent on their related manufacturing processes. So metal machined, metal stamped parts, plastic injection molding, as well as plastic extrusion processes. All of these processes are prime opportunities to apply predictive analytics to analyze them. And the goal is for better precision, which is key to medical and surgical devices, as well as higher quality and lower costs. Now, interestingly, studies on smart manufacturing over the past 4 to 5 years show it's the medical device supply chain is actually lagging other industries such as automotive and electronics, which is completely understandable because it's a highly regulated industry. So change, adoption of new approaches, it's slow. But there's another reason. Medical device supply chains often are made up of SMEs, small and medium-sized enterprises, also known as mom and pop shops, or these days, conglomerates of former mom and pop shops. Therefore, they don't have the same level of resources as their tier 1 customers do when it comes to researching and adopting these new methodologies. And I think this is where our company, Oxys, is focusing on the democratization of Industry 4.0 technologies and services. My advice to these SMEs is to, one, find partners like Oxys, like Martin, like John, because actually more is better, okay? Secondly, to focus on a real issue versus boiling the ocean. Companies make more progress when they are solving a specific issue as opposed to necessarily implementing something company-wide, like an MES system for the shop floor. Second point, engage and train your frontline employees on IIoT data, predictive analytics, and other Industry 4.0 technologies and methods. Because at the end of the day, studies showed that the organizations that follow these points are more successful than those who don't.
I love it. I have another question for you here in a second related to supply chain and IIoT data. Before we get there, though, John, maybe you can set us up for this. I've got let's say a more basic question. How does supply chain relate to predictive analytics when scheduling maintenance in manufacturing?
Well, the way a lot of companies operate, there's a planner and a scheduler that's looking at, they know what orders are coming into they're coming in and what orders need to be scheduled and produced. And so usually what they have access to is they have access to what are the raw materials in the factory. They may have access to, what machines are there and what machines are available there. What's the labor? What labor, do I have available that week to produce these products? Usually what they don't have access to is any of the maintenance records, any of the equipment on the shop floor. That's usually run by the plant manager has access to the maintenance, the scheduled maintenance, the predictive maintenance, any of that type of stuff. So the planner is really running blind. They have no idea. They can make a plan about what should be produced this week and this month on the production runs, with kind of working in a vacuum to how the equipment actually is. Now, a lot of imagine if this planner actually has access to that information as well. They know that the equipment, this equipment in the production line, this needs maintenance. They can then readjust their plan, readjust the schedule and the production run, and have a better holistic view of what should be done and what should be planned. So that's something that right now most companies they kind of silo, the production floor versus the planning.
Cliff, another question for you then around this topic. You were just speaking to your medical device industry experience, right? I want to talk more around, hey, what opportunities do you see for that industry's supply chain, right? How can those supply chain manufacturing organizations unlock opportunities through IIoT data and predictive analytics specifically?
Sure. And actually, before I go there, Chris, I just want to again emphasize that predictive maintenance, for that matter, also prescriptive maintenance, which to John's point gets to the root cause of why you need to do that predictive maintenance. And it actually is a competency somewhat considered above predictive. It's extremely important to our customers. And we at Oxys have the know-how on how to deliver it. After all, as we mentioned before, you're not making money if your machines are down, especially if it's unplanned downtime. Okay, so that said, one of the lessons I've learned from my product development days is VOC, voice of the customer. And that begins with listening to your customers and understanding their challenges. So that's what we've been doing, listening. And what we've heard from our customers is after reducing downtime, process optimization is the key to their continuing success. In the case of our CNC machining customers, especially those in the medical device supply chain, that process optimization translates into tool optimization. And let me just explain what I mean by tool optimization. Once a CNC program has been locked into both the performance, precision, and accuracy, as well as the quote quality corners of the triangle I've referred to, cost is the last parameter or corner to optimize. So getting maximum tool life without breakage and maintaining performance and quality while doing so is the key. All right. So we have another example, again, from our Spanish partner, Angura. It's a tool-aware focus use case, a proof of concept in the EU. It's still underway, but well into it. The application is heavy CNC machining for a railway systems manufacturing organization, where they take rough castings and they're finished through CNC machining. We have some great results to date. The first of all, actually being able to detect a broken cutting edge on an end mill tool, and also being able to detect deficiencies between actual versus target machining parameters. In this particular case, we were able to detect when spindle head angular speed wasn't achieved within the current program time window. Now, in both these cases, real-time anomaly detection was achieved, which enables intervention and corrective action by the machine operators. So, and just to know, I want to say, we really kind of feel this is our secret sauce at Oxys and Angura, is the ability to acquire and analyze time series data, quote, at the edge, at the actual machines. So getting back to the POC, as I mentioned, it's still underway, and we're currently at this detection and alert level now. However, we are developing predictive interventions for both tool wear and breakage prevention. I want to shift to a second example that kind of contrasts the big machining process of the EU case with a pending medical device supply chain CNC machining process POC that we have pending here in the US. And in this case, it's a matter of fine machining of small, high precision parts. However, the good news is we're able to apply the same tool optimization and predictive intervention methods as we were in the heavy machining case in the EU. And the current goals of this pending POC are to improve part quality and reduce variation in SPC, statistical process control samples, as well as reduce discrepant parts at the in-process inspection checks. So coming full circle, I just want to say these goals were established through the VOC process, targeting the current customer pain points of part production and yield, as well as downtime due to corrective actions for the quality of the parts. So I think those are a few good examples of process optimization that's still achieved through predictive analytics.
I love that. I love that. And Martin, I've seen you nodding along during the past couple answers. I want to make sure we give you an opportunity to jump in on this topic too.
Well, I was going to say that's all well and fine, Cliff, but you're talking about materials which are fairly well defined. There's a fairly limited variation of materials going into that CNC machine. Let me give you an example which is a little more variable. Frozen French fries. The potato, the raw material going in, is very, very variable. Size, color, quality, all of those things, the moisture content, very, very variable. So think about frozen French fry plants. Raw potatoes coming in, they get peeled, they get cut, they get blanched, they get fried, they get frozen. And different customers have different specifications. Size, color, etc., etc. So think about that from a puzzle, an analytics perspective. What is the optimal amount of peeling to do to avoid wastage? What is the right speed to fire them through the cutters in order to not block the cutters and not dull the cutters, etc.? What is the amount of time required for blanching and frying to get the optimal color for what the customer needs? All of those different aspects. So think about that as an analytical model, and how do you predict the behavior of the incoming potato to actually get the outputs you need? And just to use it as an entirely different type of example of how predictive analytics and models can be used in order to optimize the production coming out of the fry plant. And it's about not only speed, but it's about usable output. What level of rejects you're going to get if you get the temperatures wrong, you get the wrong color, the wrong size, etc., etc., etc. So I wanted to throw that in there as a very different type of example that a lot of people might be able to relate to, that is very, very variable, an awful lot, hundreds of different variables that can relate to the end output. And just give that as an example, get people thinking.
Sure. And actually, if I could just build on that, Martin, first of all, just want to go back to quote, consistent material. Time and time again, over my experiences, all it takes is a new batch of incoming material, that's used after months and months of production, that there is a ground shift that takes place when that new material comes in, even though it's within all the parameters that are specify the material, it's still different. And you need to be able to use these tools to actually sense those changes right from the very beginning. I also want to say a great example about the French fries. We actually also at Oxys had done a continuous manufacturing operation for a lyophilizer, a large lyophilizer in the pharmaceutical industry, where we were actually monitoring over 56 different channels of material and actually successfully predicted good and bad lots. Only, a few, actually half a day into a multi-day process. So I agree with you. Predictive analytics really turns on the heat when the more variables you throw at it, the more capabilities they are.
Yeah, Martin, it's 1:30 p.m. here, and your French fry example just reminded me that I haven't had lunch yet, but that's okay. This conversation is good. We're at about the halfway mark. So just a quick announcement for everyone: keep the questions coming in the Q&A. There's a short list of questions there that we're going to get to probably here in about 15 minutes as we get through, let's say, our final round of questioning. And a little spoiler alert: there are a number of questions around artificial intelligence. So that will be part of the discussion coming up. We'll make sure we address those topics since it's already dominating the Q&A right now. But to wrap this one up, Cliff, you gave a number of examples around reducing variation, part production, yield, etc. Right? These are areas predictive maintenance. And so my question is, what are these the short list of other applications where predictive analytics can be used to address manufacturing challenges? Are there other critical ones you'd add to that?
So again, I think the tool optimization example is a good something where you kind of shift away from the machine and really look at what is it producing, right? I think one of the things that we know is the advantage of, say, first going after these tangible challenges on a specific process is once you put these systems in place, then a lot of the other condition monitoring types of things come along with it. So OEE, overall equipment efficiency, and things like mean time between failures, all these things, remaining useful life, which is along the lines of tool optimization. All of these things come into play, but at the end, the result, is the same when they're applied, which means minimize downtime, optimize the performance triangle of performance, quality, and cost.
Excellent. And John, I'm going to pass it back to you here as we shift the conversation, really focusing around IIoT data and even that question that I posed to the audience at the start, right? To kick it off, John, what sort of IIoT data needs to be collected for these situations? And can you explain how the data is analyzed to predict failures? Kind of back to one of our central tenets of this conversation.
Sure. So if we focus on mechanical failure, which again is roughly almost 50% of the reason for unplanned downtime, there are a lot of things that you could look at. However, I think that there's the most common ones right now are being used are vibration sensor data and electrical current draw on the equipment, acoustic, and also vision-based data like laser data on moving parts to detect it. So essentially, looking at all of those things there, we could collect the data. Now, what happens is a lot of times these, you could put sensors on old equipment. Some new equipment has sensors built into it, so you could retrofit older equipment, etc. What I find is that some companies, they just collect, sensor data, continuously. And what we feel is that you don't really need to collect data continuously. What you want to do is look for a state change. So when a machine is running in a steady state operation, it's going to have a vibration, it's going to have a certain rhythm, and really only what you really care about is when it's changing, when the state is changing, etc. The other thing is when you look at the main mechanical components, there's bearings, there's gearboxes, there's shafts, there's rotating parts that can be misaligned, and most companies that make bearings, that make gearboxes, they when they make these in the factory, they record all of the vibrations, etc. So every company that makes a bearing has a template. There's a signature about what it's supposed to look like when it's operating at its ideal state. And so really what you want to do is when you're collecting the data, you're comparing the ideal state of the bearing or the gearbox to if it's not ideal and it's not matching up, and then therefore you can detect if it's not running in the optimal system or the optimal way, then you know that there's an anomaly there, and you can investigate a little bit more. And usually, as the anomaly changes, and it's usually going to start off small and then increase over time. Then you can kind of track that and then have a timing of when the system is going to fail. Okay.
Great answer. And we've got about 20 minutes left in our conversation, and we're entering kind of the final round of questions before going into the Q&A. So, Martin, I'm going to start with you here. And this is the question that I really posed to the audience at the start of our conversation today. And I want to get we're going to do a roundtable on this one, right? So, Martin, why should your CEO care about IIoT and collecting manufacturing data?
Well, I think the bottom line, if you look at what this is all about. If you're avoiding unnecessary downtime, you're avoiding failure, you're optimizing your processes. That means you're getting greater throughput, yeah, less rejects for quality purposes. That leads to high revenue. Yeah, so you're getting increased capacity with minimal extra investment because you're making the most of what you already have. Yeah, this is not about adding new machines. This is saying, how do we increase the productivity we already have? Yeah, and one of the big ways is avoiding downtime. Yeah, there's a lot of companies that don't properly measure downtime. And the first time they actually put some form of sensor to say, is the line started or stopped? Is the line running at full speed or running at lower speed? And they're mostly shocked to find they've been reporting, I don't know, 10% downtime or something like this. And they suddenly find when they actually look at automated stats like that, that the amount of time they're not running at full speed can be 30%. And they're really, really shocked. They don't believe the numbers. And you see a lot of those things. So that, that kind of improving that capacity from what the assets you already have, that increased revenue. Yeah, your CEO is going to love you for that. Improve profitability. Yeah, that whole thing around if you're reducing the cost, reducing the wastage, then yeah, that leads to better profitability as well. Yeah, improve transparency of your business performance. Yeah, if you're not collecting data, you really don't know what's going on in your factory properly. Okay, you can say we've produced X thousand parts or whatever it might be, but do you actually know how much it costs you to produce those parts? And if you're measuring the data, if you're using predictive models, you're driving all of those things. So your CEO is going to be interested in that stuff. Yeah, and all of that, yeah, that improved OEE, reduced downtime, all of these things, he's going to love you for. And I think there's been a couple of kind of comments and questions in there about, surely this is all very, very expensive. Yeah, use of artificial intelligence, predictive model. I think one thing, this is a comment that comes up a lot. I would throw in there that it doesn't have to be massively expensive. Most PLCs have a lot of sensors built in already. Just by plugging into those to start with, start gathering basic data. Yeah, some low-cost IoT sensors to measure whether a line is moving or not. Yeah, there's a lot of very low-cost things you can do to get started on this. All of those will show benefits straight away. And there was also kind of other comments related to that sort of thing. So it doesn't have to be massively expensive, and it can deliver a large amount of improvement.
Yeah, I think you said it very succinctly right at the beginning. That kind of was a good summary for the rest of your answer, where it's like increased capacity with minimal extra investment, right? We hear about, of course, profitability, transparency. CEOs are going to love that, but it's a very CEO-esque answer as well, right? Summarizing it into, hey, I'm going to get you more capacity. And by the way, it's not going to cost you having to spend a lot more money. It's not like buying a new piece of equipment per se. Great way to kick this off. John, same question for you. Why should someone's CEO care about IIoT and collecting manufacturing data?
Yeah, it's again, adding to what Martin said, it's essentially, it's not as complicated and as expensive as people think. Now, if we look at a typical downtime, on average, a factory loses $260,000 of productivity per hour, and an average outage takes 4 hours. So that's on average about $1 million for an unplanned downtime event. Okay. Now, most of these things, if you look at these, sensors and a system to monitor it, we're not talking about millions and millions of dollars. We're talking about tens of thousands or even maybe $100,000 to implement a system that can do condition-based monitoring and predictive maintenance on a factory floor. So the ROI is really months from installing it. Okay. Now, if you look at a lot of industry 4.0 other solutions out there, there's digital twin, there's artificial intelligence, there's a bunch of other things that are very complicated. You need to get buy-in from other parts of the organization, and it's a much bigger decision, a multi-million-dollar decision for a company to implement. The plant manager or the maintenance person of a plant could relatively easily install a predictive and condition-based monitoring system with a couple people on his staff and monitor it and be up and running very quickly. So it's one of those low hanging fruits of the industry 4.0 world that really anyone could do relatively inexpensively, and with a lot of ROI to receive that. Yeah.
Yeah, I love that low hanging fruit of the industry 4.0 world, right? I've used the phrase like digital transformation light, if you will, like a light beer, right? Not all of these things need to be some multi-million-dollar enterprise-wide investment. There's some really easy things that you can get started on for relatively minimal investment that can have a high impact. So, well, we're here at the last formal question of this before we get to the Q&A. Cliff, same question for you around IIoT and collecting manufacturing data. Why should your CEO care? But I'm going to add to this a little bit because I know that you've reviewed studies of leaders versus laggards in the application of predictive analytics to manufacturing operations. So, what are some takeaways for organizations to be successful, right?
Yeah, thanks, Chris. I think along the lines of IIoT data and what to be gathered, kind of just backing up just a little bit to comments from John and Martin. First of all, I would say, again, to John's point, all of the additional sensors you can put onto a process, we've actually used all of those, and we definitely are behind them. To Martin's point, the best place to start is if there is a controller involved in the process you're working on, the PLC's data that it's gathering to keep in control is real-time data that is a treasure trove. So in both cases that I mentioned earlier, whether it was the CNC machines or the lyophilizer, both of those PLC controllers gave us a wealth of knowledge to start with, and only then we selectively decided if additional sensing was needed. So that was great. The other point was about what are you actually detecting, and a great point came from John about that anomaly detection is critical. I will offer that trending is also another important aspect. And we, again, through different methodologies, and I know there's a lot of questions about AI in there, AI machine learning, we'll get into them, but another technique from the machine learning world is a BIC, or a Bayesian information criteria. We've effectively used that to tease out the subtle shifts that take place in a trend over time. So it's not just the anomaly detection, but also trending. So, okay, why is this? Should this be important to CEOs? Well, of course, I don't think there's any CEOs out there that purposely intend to be a laggard as opposed to a leader. They want to be a leader. So I wanted to actually tell you a little bit more about that study that you mentioned. And first, let me just give credit to the collaborative parties that initiated the study. I'm going to be referencing McKinsey & Company, a well-known, a well-known consulting firm up here in the Northeast, and MIMO, which stands for MIT Machine Intelligence for Manufacturing and Operations. You can always count on MIT on a really good abbreviation. So the study is the MIMO McKinsey MI Machine Intelligence Research Study. And I'm going to provide a link to that study in the chat box. The current findings are based on its one-year survey with about 100 companies. And the second year of the survey is now open. And it has a goal of actually having 1,000 companies to participate. So I highly encourage any manufacturing organization that's currently on a quote, and you mentioned this, Chris, a digital transformation journey, whether it's light or full blown, or if they're considering starting one, to actually take this survey, as it will be a multi-year study. So let me share some of the key takeaways that I've actually mentioned previously in our discussion so far. First of all, as we said, it's focusing on what distinguishes the leaders from the laggards. Okay, and along those lines, one of the interesting point is they describe various types of groupings or clustering in the survey. And one group was called executors and another was called planners. And the executors are actually doing better than the planners, okay? And these executors do exactly what I mentioned before. They focus on a specific pain point and they look to fix it, as opposed to necessarily taking what the planners do is they try to create the perfect, complete solution and wind up boiling the ocean. And many times, trying to employ technology like an MES system before they've really targeted the true pain points and the goals of what they want to achieve, in the actual journey. Third, and this is another point I mentioned before, is leaders train their frontline employees on these very topics that we're discussing today: IIoT data, predictive analytics, other Industry 4.0 tools, and the results are significant. Their progress above the laggards is measured in the KPIs on the order of 5x. So, significant orders of magnitude better, than the laggards. So, and I'll kind of give my final thought on this, idea of where should they be going? And again, maybe before I do, I just want to emphasize what was mentioned earlier. I think another good phrase for CEOs to keep in mind is it really is an ounce of prevention is worth a pound of cure. And you know something, if you price it out and it's not, then it's not the right solution. So finally, let me just say this. The goal of this digital transformation that MIMO is kind of concentrating on is the idea of, quote, true machine intelligence, which is they define as a machine that can actually adjust its own performance autonomously based on historical and real-time data. Now, obviously, that's a very lofty goal. It's not going to be here next year. It's going to be in the future. However, as we described today, you can make significant gains in your organization just by taking the first steps of the journey we've described and the topics we've discussed on this panel.
Excellent answers across the board today. Excellent insights. I've wrote down some of my favorite quotes from these past answers. We've got just under 10 minutes here for our Q&A. I've already taken a look at the list to kind of lump some of these together so we can answer them most effectively. As I'm looking through this list and putting them together, prioritizing them a bit more, Martin, I'm going to throw one to you first, because I know that you actually brought up AI and machine learning in advance of this as something that would be worth talking about. So a couple questions that fall into this category, generally asking similar things, right? What are the next challenges to be solved in manufacturing by AI? Why invest in AI for large equipment? I think, the way you've addressed this before is, hey, how can AI and ML help drive improved manufacturing results? So if you want to give your kind of catch-all answer to that, I'd love to hear your thoughts.
I think the bottom line comes down to is how do you use data to make the right decisions? And that's the fundamentals of Industry 4.0. If you really boil it down, it's how do you use data and information to make the right decisions to optimize your manufacturing. And I think if you take that then to the next level is digital twins, use of artificial intelligence and machine learning, and all of that really comes down into the same way, is how do you take that input data, which is coming from your machines, fed from PLCs, from IoT sensors, whatever, and then use that and model that data to predict the behavior. And that's really what this is about. It's about predicting behavior and predicting outcomes based on that. And artificial intelligence, machine learning help do things that we can't easily do. Taking thousands of parameters and seeing the patterns and the pictures that emerge from that in order to maximize your throughput, improve your quality, reduce failures by predicting when things are going to fail, so you can actually do. So I tried to boil it down to the whole thing. That's, yeah, you really fundamentally come down. It's using data to make the right decisions.
And another similar question that builds on that, and I'm going to be going a bit rapid fire here since we're up against the clock a bit. But how active are predictive maintenance predictions typically, right? And someone was also asking, hey, has AI helped make things more accurate? Anyone can raise their hand on this. Maybe Cliff or John, if one of you want to.
I'd love to jump in on this. So again, I think we could have another 3 hours on AI and machine learning alone. I think very simply, I just want to say, for me, AI and machine learning are basically the numerical computation methodologies that allow the predictive analytics that we're speaking of today. And the point is, get started with it now, because they'll only improve over time, as will the hardware that can process it even faster. So don't wait, because you can get great gains from it today. As far as, is it changing things? It's changed things for our customers relative to replacing spindle bearings. And it's also helped, in optimizing machining processes. So the productivity gains are very real from the tools that are available today. And that's how come we employ PhD data scientists, because they understand when to use unsupervised machine learning methodologies, as opposed to various types of neural nets trained on supervised learning of reinforcement data, etc.
We have some pretty tactical questions here as well that really get pretty specific. One is, hey, in order to do predictive analytics, you need to make investments in wireless devices, IoT, cloud processing, etc. And the question is there like a minimum amount of rotating equipment or a minimum amount of assets that you need to have to realize an ROI, considering the investments that need to be made in the tools that make this possible?
I'll take that one. So it really isn't the number of devices, it's the criticality of the device. So in other words, if one device, we have a company, they do chicken farming, okay? And there's a device that spins a chicken around, and I don't want to get into the details, but when that bearing breaks, the entire production line is down. And so there's one bearing that they need to investigate, and they need to make sure runs, or the entire production line is down. And so what happens is, if you have one item that's going to bring down the production line, it's worth doing predictive maintenance. Now, of course, the more machines you have, the more important, the more you can amortize the cost of it. But it doesn't really matter. It's really just if you're going to keep the production line up, it's gonna benefit you.
All right, we're here nearing the end of the session, so just a couple more questions we have here. Let's look at this one. Do we have more deep learning type of application examples instead of beyond vibration data analysis? Is one that's here at the top.
So again, I think the point here is, do you need deep learning in order to predict what you're trying to get to the bottom of? And again, I just want to caution that typically when you start to talk about deep learning and being able to train those, you're talking about large data sets, or you have to create them through what we call reinforcement learning. The point is, first of all, make sure that you're aligned with a partner that has good data scientists, science fundamentals that can basically guide you into the least computationally rigorous methodology that will still get you, the good results. So that would be my recommendation.
All right, and I think this might be the last one we have time for. Question specifically for Martin. would you, where is this one? Okay, here it is. How would you use IIoT data to generate revenue?
Thank you, Joanne. I know who it came from as well. What I would say is use of IoT data to generate revenue. If you're taking just in a manufacturing setting, then the simplest answer is, yeah, use it to understand what is going on. And that then gets you into the whole thing around revenue. So for example, if you're buying just a couple of cheap IoT sensors, understand when your line is up or down. That will give you an almost immediate payback. Because if you understand when it's not running at full speed, then you'll start to understand immediately your causes of downtime, and therefore that will generate additional revenue for you. So it's a real simple answer. It's a more complex than that, but start simple is what I would say.
All right. Well, hey, we're here 1 minute till the next session, so we want to get you moving to the next part of your day. I just want to thank, hey, Martin, John, Cliff, thank you so much for taking all the time today on this conversation. Great insights across the board. I learned a lot. I hope you all did as well. So don't forget to rate the session on the way out and enjoy the rest of your time at IIoT World's Manufacturing and Supply Chain Days.